Welcome, ladies and gentlemen. Today we're going to talk about graphing absolute value equations. So we're finally moving beyond lines, all right? Our key idea today is that we're going to be creating a V, as in victory. So you're going to need your notes, pen and or pencil, and a calculator to be victorious today. All right. First thing we need to write down is our learning objective. Our goal today is that you can graph an absolute value function using a table. All right, we are going to do 3 examples today. All 3 examples need to be written in your notes. All 3 of them, okay? Here comes example number 1. So all of this on this page right now has to be written down, every single bit of it. Now, when we're graphing an absolute value, our goal is to make a V. When we're working with this, the first thing we have to do is we have to find our vertex. In order to find our vertex, we're going to take whatever is inside the absolute value, and we're going to set it equal to 0. So x equals 0. That's our x value. Now we're going to go in and we're going to find our y value. To do that, all we're going to do is plug in 0 in for x. So y equals absolute value of 0. So y equals 0. So our vertex on this equation is 0, 0. Now once we find our vertex, we're going to put that in our table. Our vertex always goes in the center of our table. So it's going to be 0, 0. Then we're going to fill out the x side of the table. So we're going to count up, 1, 2, down, -1, -2. Once we have that done, we're just going to plug it into our original equation to find our y values. So if I do the first one, y equals absolute value of 2, that's just 2. So I have 2 there. Y equals the absolute value of 1, which just equals 1. Y equals the absolute value of -1. Now if we look at this one, anytime we have absolute value means that things are going to come out positive. So we're going to get a positive 1 here. And then last but not least, we have y equals absolute value of -2, which is just going to be 2. Now ladies and gentlemen, every time you do this, your vertex is in the middle. The next 2 should be the same. If they're not the same, you need to check your math. And then the 2 after that should also be the same every time. And if we keep going, the third one on the top and on the bottom should be the same. Once we have our table filled out, now we can graph it. So we're going to start here, 2, 2, and then we have 1, 1, 0, 0, -1, 1, -2, 2. It should be a V. Arrows on both sides because it's going on forever. That's very important when we're talking about domain and range coming up here. Once we have that, we can do our domain and range. Now, from what we've already done, we know our domain. We can plug it in. It's going to go on forever, both directions. So we're talking about -infinity to +infinity. Our range, on the other hand, we are stopping right there. So we're going from 0 all the way to +infinity. Now increasing and decreasing we've worked with a little bit. We're going to work with it some more. Increasing is where my x and y values are going up. So this side is increasing. That's a positive line there. So we're starting at our x value, which is 0, and we're going all the way to +infinity. So it's increasing from 0 to +infinity. Now, when it's decreasing, here, look at this, I have a negative line. So we're starting at -infinity, and then we're going all the way to my x value, which is 0. So -infinity to 0. Then last, but certainly not least, we're going to do max and min. Now, we have a minimum because it's going to meet down here at the bottom. This is our minimum point. We can't go any further lower than that. So the point is 0, 0, but when we're talking about our min or max, we're going to write it as y equals. So y equals 0. All right, ladies and gentlemen, there's example number 1. Moving on to example number 2. Here's example number 2. So first thing we have to do is we have to find our vertex. When we're doing that, we're going to take what's inside the absolute value and we're going to set it equal to 0. So 2x plus 1 equals 0. To solve this, we're going to subtract 1 on both sides. So 2x equals negative 1 divided by 2. X equals negative 1/2. There is our x value. Now to find our y value, we plug it back into the original. So y equals absolute value of 2 times the negative 1/2 plus 1, absolute value minus 4. Y equals absolute value of negative 1 plus 1 minus 4. Well, everything in here is going to be 0, so y equals 0 minus 4. Y equals negative 4. So now that we have our vertex, it goes right in the center of our table, negative 1/2, negative 4. Now I'm going to count by halves. So negative half, the next thing would be 0. Next thing after that would be a positive half. If I'm going the other way in the negative direction, if I subtract another negative, I'm at negative 1, and then negative 1/2. Once we get there, we're going to plug these in to the original. Now I'm going to give them to you, but if you have to go through, plug it in, check your work. So the first one, if I plug in 0, I get negative 3. If I plug in 1/2, I get negative 2. If I plug in negative 1, I get negative 3. Plug in negative 1/2, I get negative 2. Remember, these should be the same. If they're not the same, we need to check it. Once we have our table filled out, we're going to come over here and graph it. So I go negative 1/2, negative 4 right there. Then I have 0, negative 3, negative 1, negative 3. I have a negative 1/2 and negative 2. And then negative 1/2, negative 2. So now my V looks like this. It's a little bit skinnier and it's moved down, but there's my V. Our domain, ladies and gentlemen, is not changing. We're still going out in both directions. So we're still going to go from negative infinity to positive infinity. Our range, though, is going to change a little bit. Because if we look here, this is where I'm starting now. I don't go anywhere lower than that. So I'm going to start at negative 4. And then I'm going to go all the way to positive infinity. Now, increasing and decreasing doesn't change that much at all either. If we look at this one, I'm increasing, so I'm going up from here to here. I'm starting at my x value, which is negative 1/2, and I'm going all the way to positive infinity. So I'm increasing from negative 1/2 to positive infinity, and I'm decreasing because my line's going down. I have a negative line there, whoop, a little off, from negative infinity all the way to my x value, which my x value is negative 1/2. So negative infinity to negative 1/2. Now, if we're talking about max or min, this is our lowest point. We don't have a highest point, but we have a lowest point, so we have a minimum. And that point is at negative 1/2, negative 4. But when we're talking about max and min, remember, we put it in terms of y equals, so my y is negative 4. All right, there's example number 2. We're going to finish it off. Here's our last one, ladies and gentlemen, example number 3. Now this one's going to look different, so please, please, please make sure that you have this one in your notes. All right, first things first, ladies and gentlemen, we're going to find our vertex. In order to do that, we're going to take what's inside the absolute value. So I have x minus 2, and it's going to be equal to 0. To solve for x, I'm going to add 2 to both sides. X equals 2. There's our x value on our vertex. Now our y value, we're just going to plug it back in. So y equals negative, don't forget about that there, absolute value of 2 minus 2 plus 3. Well, y equals negative 2 minus 2 is 0 plus 3. So y is just going to equal 3. Now remember, we put our vertex right here in the center of our table. So I have 2, 3. Then I'm going to go above and below that. So I'm going to have 3, 4, 1, 0. Plug in my x values to find y. So at 3, I'm going to get 2. At 4, I'm going to get 1. 1, I'm going to get 2. 0, I get, 1. Now remember, these have to be the same. They should be the same there. Once we get this far, we're going to graph it. So I have 4, 1, 3, 2, 2, 3, 1, 2, 0, 1. Now this one, ladies and gentlemen, this one is pointing downward, which is absolutely fine. It's an upside down V, which we can have. So we still have our V, so we're good there. Our domain is not going to change. It's still going on forever both directions, so we're still going to rock negative infinity to infinity there, positive infinity. And our range, though, our range is changing a little bit. We have nothing down here in the negative world, so it's going to be negative infinity all the way up to here. This is where we're stopping at. We're never going to go past that, so it's going to be negative infinity to 3. Now, our increasing and decreasing are also going to be a little bit different. If you look at this, now my increasing is going to happen here. I'm starting, it's a positive line there. So from negative infinity all the way to my x value, which is 2, that's my x value. That's where I'm increasing. So negative infinity to 2. I'm decreasing. I'm starting at 2, and then I'm going down to positive infinity because we're talking about x values. So here I have 2 to positive infinity. Now, last but not least, we're talking about max or min. Now, here's our point. Now it's our high point, so it's going to have a maximum. And that point right there is at 2, 3. But when we talk about maximum, remember, it's going to be y equals, and my y is 3. So make sure, ladies and gentlemen, that you have all 3 of these examples written down, please. All right, moving on, I have one more thing to show you guys. You can write this down if you wish. If you don't want to, that's fine. A little summary. First thing, we're graphing absolute values, which is a V shape. When we are doing this, we have to find the vertex by finding the x value that makes the absolute value expression become 0. So what's inside the absolute value, we have to set equal to 0. Then we're going to complete the table, plot our points, and it should always be a V shape for victory. So if it's on a V, we need to check it. All right? That is all I have for you guys today. I hope you go out, have a wonderful day, and I will be seeing you soon. Bye.